Okay, this is Unit 1, Building Blocks of Geometry, Sections 1.1. Actually, these combinations right here, we're going to talk about the terms of geometry and then construct segments, midpoints, and perpendicular bisectors. First, most important thing is the building blocks of geometry. They're also called the undefined terms of geometry. And they are point, line, and plane. Point, line, and plane. And we're going to go over these definitions next. First one, point, 3 bullets. Okay, it's 0-dimensional. Okay, meaning it has no size. It looks like a dot. And then you name it with one capital letter. Okay, naming them is important. So there's our point, and then it's called point A. Okay, so you just have to write one capital letter. Next one is line. Okay, again, 3 bullets, and you can abbreviate, summarize, whatever. Just make sure you get the most important things down. This one is 1-dimensional. Okay, meaning you can have its length lines. Okay. However, there's no specific length to a line because it goes on forever and ever. It's an infinite number of points blended together, and they extend and they drift off in opposite directions. You name this with 2 capital letters from any 2 points on the line, or 1 italicized letter. So we'll have an example of that. So here's a picture of a line. Okay. So there's 2 points on there, and there's that italicized letter off to the right. So there's 2 ways you can name it. This first way, okay, or this way. To me, those 2 are the exact same thing. Or like that, you write out the word line, and then you click the and them. Okay, whatever's out here. Next one is plane, the third one. This one is 2-dimensional, meaning it has a length and a width. This is considered a flat surface, extending infinitely forever and ever in all directions. You name this with at least 3 non-collinear points or 1 italicized letter. So here's some examples of some planes. You've got one here. There's another one, and there's another one. They're all examples of flat surfaces. Okay, think 2-dimensional. So here's how you would name just this first one. Okay, this one here is how you name it. You can name it with this symbol right here. This symbol is important. That symbol, and then at least 3 letters. They used 4, okay, but any 3 will work. Or the other way is like that, plane M. Okay, collinear, I just mentioned it in the last slide, okay, or I mentioned non-collinear. So here's what collinear means. All it means is on the same line. So you have all these points here. So we're just going to name some collinear points. So here's this set of points that are collinear would be A, B, and C. That's a set of collinear points. Another set of some collinear points are D and F. Okay, because those groups are on the same line. So non-collinear would be not on the same line. So we'll just name one set of non-collinear points. Okay, and you need at least 3. Okay, so that's a good note to me. At least 3 points, because any 2 points are technically collinear. Okay, so you need at least 3. So in this case right here, I could choose A, be on any of the sets because that's the one on those two lines. You got the orange line and the black line. Coplanar. Coplanar means on the same plane. Okay, so here we have an example picture of two planes. We've got a blue plane and we've got a yellow plane. You'll notice the red points are on the yellow plane and all the black points are on the blue plane. So to name a set of coplanar points, let's talk about the red ones, okay? Being the yellow plane. You've got C, E, and F. Now that's a set of coplanar points. Okay? The other set of coplanar points, meaning being represented on the blue plane, we've got A, B, T, and G. Okay, so if I ask you to name a set of coplanar points, that's how you would do it. Non-coplanar. Non-coplanar means not on the same plane. So working with that same picture, let's name one set of non-coplanar points. Meaning not on the same plane. Okay, so here, you can pick one from the yellow plane, let's just say F. F, A, and B would not be on the same plane. Okay, again here you want to have at least 3. Okay, because again, these 2 points are on the same line, therefore would be on the same plane. Alright. Line segment. Okay, definition of a line segment has 3 bullets. Has 2 endpoints, and then all the points in between is part of a line, and you name it using the 2 endpoints of that segment. Okay, so here's a picture of a segment, and here's how you name it. So again, it's 2 endpoints and all the points in between. It's part of a line. You name it using the 2 endpoints. Either one of these will work this way or this way. You don't ever have to write both. Congruent. Congruent means same size, same shape. Okay? And that's the correct symbol that you would use. So you get used to seeing that symbol. Just remember, same size and shape. Okay? And if you plan to turn it rotated, that doesn't matter. It just has to be the same size and shape. So congruent segments would look like this. You have segment OC and segment UR. Therefore, OC is congruent to UR because it has the exact same measure on both of them. These red tick marks, by the way, those are important to know. Whenever you see those tick marks on segments, that means they're congruent. So they don't have to have the measure stated. You just see tick marks, that means they're the exact same size. Segment addition. Okay, we're going to add segments in a certain way, and you should be able to solve problems that way. So what this says is if in order to add segments in this particular way, all points are going to be collinear. So A, B, and C are collinear. Okay, and these in between A and C, therefore this statement right here, this formula, can work. So all it's saying is that if I take this segment here, AB, and I add it with BC, well then that gives me the whole thing, which is AC. Okay? AB plus BC equals AC. So simple problem would be if this is 5 and this is 8, what would AC be? 13. Okay? Just add those two together. We'll make it more challenging and use algebraic expressions. Okay, so now constructing. We're going to use a compass on the straight edge. So the first things first, whenever the problem says to construct, okay, you have to use a compass and a straight edge. So a construction is a geometric drawing that uses a compass and straight edge only. So compass and straight edge only. Okay, so you gotta get pretty comfortable with it doing your geometric art, line design, and circle design. First thing we're going to construct is copy the segment. So it's 3 simple steps. First step is listed here. Second step listed here. Third step listed here. The first step is to just draw a long line. The second step is to place your compass on the segment that you're copying and get the width of it. And then the last step is to just put it on a new line and make an arc. Okay, so let's practice it down here at the bottom. Let's get that one right there. So the first thing you want to do is draw a long line. That's the first step. Then you want to use your compass and get the width or measure with your compass how big that segment is. Okay. Then we're going to place an endpoint on our first line. We'll just call it C. Then we're going to place our compass with that exact measure over here. And we want to make an arc like that. And then this is our endpoint right there. And so we'll call that D. Okay, so we just constructed a segment congruent to AB. AB is congruent to C. One way that you could do number 3 right here, we need to make one segment that is congruent to AB plus EF. So something that is congruent. So we'll get some other letters. Let's say LN. We need to make a segment LN congruent to AB plus EF. So first things first, start off with a long line. Then you want to get the measure of AB first. So place your compass. With the AB first. Then you want to come down here and place your compass on the left. That will be one of our endpoints. And then make an arc. That's the size of AB. Now we need to add EF. So EF, we're going to place your compass on one of the endpoints. And then you want to get the width of that one. And so here, we want to add this on to this one. I almost didn't make my mind long enough. Okay, so there it is. So this endpoint will be L, and this endpoint will be M. Okay, so on midpoint. What's a midpoint? A midpoint is a point on a segment that is the exact same distance from both endpoints. So here's a picture. So in this case here, we have this point right here representing the midpoint of segment LS. So whenever you have that, that makes LA congruent to AS. Okay, let's learn how to construct a midpoint. Again, 3 simple steps. Your first step is right here. You want to place your compass on one of the endpoints here, and then you want to make a setting greater than half the length. So just go more than halfway. Then you make an arc like I did here. Then you place it on the other end, and then you make another arc. So then now you should have 2 arcs. And then all you do is line your ruler up with this endpoint, or intersection point, and that one, and then you just draw your midpoint there. Okay, so let's practice that right there. Okay, so let's place our compass on one of the endpoints. And then make sure your compass is more than halfway. So value and then that one. Now it's time to line up your ruler. So put your ruler on both intersection points like that. And then all you have to do is make the midpoint, which is right there. Okay. This midpoint right here, we'll just call it M, and M is the midpoint of that segment. Okay. Also bisect. Okay. You'll hear me say that term a lot. Bisect means you cut in half. Okay, let's do one more, the very, very bottom. It says divide this into 4 congruent parts. Okay, well, let's do what we just did. Okay, let's divide it into 2 congruent parts. Right? So we'll make one big arc here. Place it on the other endpoint. Big arc there. And then use your ruler and line up the 2 intersection points. So we just divided it into 2 congruent parts. We need 4. So if you think about it, if I cut this portion right here into 2 equal parts, then I can cut this one over here into 2 equal parts, giving me 4. So basically, you're doing the midpoint 2 more times. Okay, so make your compass slightly bigger and out of the way. Get a different color here. Make an arc. Place it over here in the middle. Make an arc. Make a ruler. And there's another midpoint here. So you have to do this one more time. Or if you think about it, we're making a quarter of it, right? So you can just go copy this segment here. So if you get the width of that, over here, and there we go. So we have 4 congruent parts. I'll highlight each part. 1, 2, 3, 4. You've got 4 equal parts. Okay? Probably we'll have to label them. We'll call that point A, that point B, that point C, that point D, and that point E. So you've got AB congruent here, BC congruent there. Remember, tick marks signify that they're congruent. Alright, you want to do that for your quiz. Array. That's the picture of array. Okay? It's kind of a combination of a line and a segment. Okay? It has a definite beginning and an indefinite ending. There's how you name it. You need to write a little note here. This symbol is for particular. It must point to the right, which means this first letter must always be your endpoint. Okay, where it starts. Okay, so that first letter must be your endpoint. Okay, so that's what array looks like. People often get confused on this one right here. That's A, that's B. They make a mistake and write AB like that. Okay, that's wrong. This one should be written B first, because that's the endpoint. Then A, and the arrow must point to the right. All right, let's do a couple of examples. Okay, these right here are 2 congruent segments because of this right here. All right, this one is 3x plus 12. This one is 7x minus 16. So in order to find the length of x and the segments, what do we do with these 2 algebraic expressions? You 28 on the left, 4x on the right, divide by 4, x equals 7. Now plug 7 in, 7 goes right here, 7 times 3 is 21, 21 plus 12 is 33. So AB is 33 units long as well as C, because they are congruent. Try another one. Here we have a point in the middle somewhere, and we've got a big segment AC. So it says AB is 2x minus 9, BC is 3x plus 17, and AC, the large segment, is 43. So how do you set this one up? We've got to solve for AB and BC. Well, if I add AB with BC, doesn't that give me the whole thing? It sure does. So that's how you want to set it up. 2x minus 9 plus 3x plus 17 is equal to 43. So like terms here, we've got 5x plus 8 equals 43. Minus 8 minus 8, 5x equals 5, x equals 7. Okay, so if x equals 7, I'm going to solve for AB and BC by plugging 7 right there for x. Well, over here, that's 14. 14 minus 9, that's 5. So AB is 5. Well, you know the whole thing's 43, so why not just subtract 5 from 43? So therefore BC is 38. Yeah, 38. Okay, last problem. Here we have B here in the middle. We have the tick marks here. What does that mean about these two segments? It means they're congruent, and it also means that B is a midpoint. Okay, so B is we'll take it in now. I know that AB is 7x, so from here to here is 7x, and AC, the whole thing, is 12x plus 36. And I need to solve for BC over here. Well, is there something that we can represent BC? Yes, it's the same as this over here, so why not call that subject also? Okay, so what you can do here is you can say, well, there's a lot of ways you can do this, but I mean, just one way that I can think of is add those two, which is 14x, and set it equal to the whole thing. It's kind of like the first or the second problem that we did. Set it equal to the whole thing, 12x plus 36. Minus 12x minus 12x. That's a good thing about math. You can do it lots of different ways and still get the right answer. So whatever is easier for you in your brain. Divide by 2, x equals 18. Okay, so x equals 18. Now we need to solve for BC. Well, BC is the representation of 7x, so plug in 18 for here. So 18 times 7 is